So thanks everyone for joining us for the final webinar in this series. Today my colleague Max will build on what we did in the last two webinars and show you how you can create custom reports in Simulate. I'll now pass you over to Max.
Thanks very much, Glenn, and welcome everybody to webinar 4, where we're going to be taking a look at creating custom reports within Simulate. Just a little bit about myself, for anybody who's not seen the first 3 webinars. My name's Max Guild. I've got a background in applied mathematics, and I worked in process improvement in the banking and finance industry for around 8 years, where I got my Lean Six Sigma Green Belt certification. I then joined Simulate as a business consultant, which basically means that I, for example, train people on how to use our software, or I build consultancy models, which is generally where I will provide a user interface on a model, and that user interface allows our users to test a model or test different situations using different parameters without having the need to know how the model is built. And the final service that business consultants are involved with is coaching, and that's really a hybrid of the two. And what we'll do is we'll work with our clients to actually build a model from scratch and share all of our knowledge. So it's a really useful way to learn how to use Simulate. What we're going to take a look at today is creating some custom reports. And we're going to start building some pretty detailed reports without using any visual logic. For those of you who are not familiar, visual logic is basically a programming style language that we include with Simulate, and it just gives us an extra level of control over our simulation. So we're going to take a look at the visual logic interface, and we're going to take a look at some of the key commands that we would use as consultants when we're working with visual logic. As I mentioned, this is the 4th session. I would really recommend, if you haven't watched the other 3 sessions, to take a look at those. They will take you basically from a blank screen to the model which we see in front of us, which we'll be adding to today. So just as a little recap from those 3 webinars for anyone who missed them, we spent our time in the first webinar building the basic structure of this car manufacturing plant. We also did some experimentation and decided that it was worthwhile investing in the second assembly line. In the second webinar, we added some complexity. So we have different colors of cars being manufactured, and that allowed us to experiment with, for example, changeovers at the paint activity. It also allows us to route through different areas of the simulation for different colors of car. The previous webinar, webinar 3, we added resources into our simulation. So our resources are staff. And we also did some experimentation where we were able to test the benefits of increasing the number of assemblers from 2 to 3. And based on the increase in throughput, we actually found that it would definitely be worthwhile increasing the number of assemblers to 3. As I say, there's going to be a link sent out after this webinar, which will provide you access to all 4 webinars. So what we're going to be taking a look at in this webinar is building some custom results without any code or without any visual logic. To do that, to be building a report that basically goes down to the work item level. So a really detailed, granular report. And in order for us to be able to do that, we're going to set up a label which is going to store a unique identifier. We're going to use that unique identifier to identify which row on our simulation we're going to write the results out to. This is something we do all the time as consultants when we're building bespoke results where people want to see down to the individual customer level or the individual car or individual call level. We're also going to take a look at the button, which allows us to basically build these custom reports really easily. And we'll also take a look at clearing spreadsheets whenever we reset the simulation. So I'm just going to jump into the software now, and we've got the model which we built previously. So what we're going to do for our results today is we're going to basically, because our bottleneck is in this first section of the simulation, so if I speed this up to the end, because our bottleneck, or our main bottleneck, is in this area of the simulation, we're going to do some detailed analysis, or we're going to build a report that will allow us to do the detailed analysis to help us try and alleviate this bottleneck. So we're going to record the time that a work item, in this case representing a car, we're going to record the time that a car enters the manufacturing line. We're then going to record the time that the car exits inspection 1. So we do this quite a lot in more complex simulations where we maybe want to see how long work is spending in a particular area. We can build custom reports like this to help us with more detailed analysis. So I mentioned that we're going to be using a label to store a unique identifier, and that's going to give us the row of our spreadsheet that we want to write out to. So I'm going to create that label just now, and to do that I click on the Data and Rules tab and click on Labels. I'm not going to go into too much detail about what we do to create labels. I'm going to go through this quite quickly. This is all covered in webinar 2. So we're going to create a new label, and it's going to be called LBL ID. Equally, it could be called LBL row number. It's up to you. You can name it something meaningful for yourself.
So I've created a label, which is basically just a place to store information on a work item, and I'm going to click on OK. I want to change LBL ID to a unique number. So I'm just going to select my unique action there. So I've set up a label which tells me which row I'm going to be writing the information out to, and that's going to be LBL ID. So that tells me for each work item which row we're going to use to record the information. I also want to update a spreadsheet, or start building my custom results. So to do that, first of all, I want to create my spreadsheet. So I'm just going to click on OK there, and I'm going to click on my Data and Rules, and Information Store, and Spreadsheets. Again, this information has been covered in webinar 3. So if you'd like a little bit more information on spreadsheets, please take a look at webinar 3. So this is going to store our results. So I'm just going to call it SS Results. Whilst I'm in this dialog here, you can see in the lower right hand corner I have a Clear Data on Reset option. That basically means that I can, if I tick that, the data or the spreadsheet is going to be cleared every single time the user hits reset. As I mentioned, if we've got varying numbers of rows of data, we definitely want to be doing this so that we don't have excess rows or hangover rows from the previous run. So I'm going to click on OK there, and I can return to my start point, and I can click on Actions. I don't want to change a label, so I'm not going to click on my Add a Label to change. What I want to change is a spreadsheet, so I'm going to change anything. As I mentioned, the information that I'm going to be changing is in a spreadsheet, so I'm clicking on my Spreadsheets option here. The spreadsheet that I want to change is SS Results. If I double click on SS Results, I populate the formula editor, and I can record the results in column 1. So I'm just going to type in a 1 there. The row is going to vary depending on the value of the label. Again, we saw how to do this in webinar 3, so I'm not going to go into too much detail here, but we know that the row reference is going to be contained within our LBL ID. So I can double click on that and that will populate the formula editor for me. I can click on OK there, and Simulate has added that spreadsheet reference to the list of things that we're going to change at the start point. What do I want to change about this spreadsheet reference? I want to give it a timestamp. And that basically tells Simulate that whatever time is on the simulation clock, we're going to store that in SS results, column 1, and whatever value is contained in this label, that's going to give us the row. We're almost there. I just need to be careful about the order in which we do things in this list. I want to make sure that I set the value of LBL ID first. Otherwise, when I get to this section here, LBL ID is going to have a value of 0, and there's no such thing as row 0 in a spreadsheet. So we want to make sure that we set the LBL ID first before we record our spreadsheet result. If I click on OK and reset and run, again, we're only interested in the results, so our speed's turned all the way up. I can click at the lower portion of my spreadsheets and select SS results. And you can see that I've recorded the individual times that each individual work item has entered the simulation. So hopefully already you can start to see the potential for bespoke results and custom results. For only really a few clicks, we've started recording some pretty detailed results. What I want to do now is I want to record the simulation time whenever a work item leaves inspection 1. That way I can see how long a work item has spent within this entire section. So to do that, I select inspection 1, and again I click on my actions button. We don't want to change any labels, so I'm not going to click on my add label to change. I'm going to click on change anything because we want to change a spreadsheet. As I mentioned, we want to change a spreadsheet, and what we want to change is SS results. It's going to be column 2 this time because we want to record our exit time in column B. And again, our row is going to be dependent on the individual work item. So the row is stored in LBL ID, so I can click on OK. Once I've done this, Simulate asks me what action or what information do I want to record in the spreadsheet. Again, I just want to timestamp the spreadsheet. Click on OK, and when I reset and run, if I click on spreadsheets and SS results, you can see that I've recorded the entry time and now the exit time. So already we could export this into Excel, add a really simple formula, and that will give us the total time which the work item has spent in the simulation, or in that section of the simulation. I'm going to take it a stage further and actually perform that calculation within the software itself, just to show you guys a little bit more functionality, which will help you guys to build your own custom results. If I click on inspection 1 and actions, we're going to record how long the work item spent within this section when it leaves inspection 1. To do that, we know the entry time and we know the exit time. It's just a matter of subtracting the entry time from the exit time. That's going to give us the total time. So again, I'm going to record that in column 3 this time. I'm going to click on Change Anything. I'm updating a spreadsheet, so I'm going to select my Spreadsheets option, and it's going to be SS Results. It's going to be column 3, and again, we want to write out the row specific, or the information specific about this work item, so it's going to be LBLID, and I can click on OK. And I'm not going to set it to a unique value or anything like that. What I want to do is I want to set it equal to a calculation. So whenever I'm using a calculation, I want to use my set_to action. And that opens up this little dialog here. I don't want to set it to a fixed value here. I want to set it equal to a calculation. So I'm going to click on these 3 little dots. Again, we've seen the formula editor in part 3 of our webinar series, so I'm not going to go into too much detail around the formula editor, but essentially this is where we can perform our calculations. So for example, if I had any maths functions that I wanted to perform here, I could use all of our inbuilt formulae to help me calculate that. What I want to do is I want to, my calculation involves a spreadsheet cell. So I'm going to click on my Spreadsheets option, and it's going to be SS Results. What I want to do here is I want to take whatever is in column 2 and the unique row that I'm looking at. So again, we're clicking on Labels and LBLID. From that, I want to subtract another spreadsheet cell. So I click back into Spreadsheets and double click SS Results. And I want to subtract column 1 this time from column 2, and again it's going to be my specific row identifier. So I can click on OK there. You can see that that's populated our formulae within that bar. I can click on OK. Again, we just want to be a little bit careful of the order in which we do things. I obviously want to record the value or the exit time in column 2, so I want to move that up to the first section or to the first item in the list. That way I record the exit time before I subtract the entry time from it. Let's check and see if that's worked. So I can click on OK, I can reset, and I can run. If I click on my SS Results, you can see that I've calculated now the time that each individual work item has spent within that individual section of the simulation. So already we're building up some really detailed results right down at the individual work item level. This is a really powerful setup, and it can allow us to perform a whole bunch of analysis. For example, we could export this to Excel, draw some charts, we could export this into Minitab, for example, start using that to analyze our control charts, for example, or we could feed that into control charts, for example. So I'm going to click on OK there, and really you can do as much as you need in terms of custom reports. You can record as many custom results as you want. All you need to do is start building them up using our label actions, our actions buttons, and our change anything, and you can really build up some really nice results for only a few clicks. I mean, realistically, we could probably have done that in about 15 seconds to get to that many or that level of detail, which isn't too bad at all. So what we're going to take a look at now is kind of taking that a stage further, and we're going to take a look at visual logic. So visual logic can help us calculate even more complex results or even more bespoke results. So for example, OEE calculations are a bit more complicated. We probably want to look at visual logic to help us calculate that type of thing. Visual logic also allows us to have bespoke control over simulation objects. So if there's a really kind of complex routing option that we might want to set up, we can use visual logic to do that. If our default interface doesn't provide that option. We can also create user interfaces. As I mentioned, we do that as part of our consultancy projects, but equally we could, we've seen our clients build kind of usable tools which let's say the factory floor will use to manage their staff, or their call center will use on a day-to-day basis. They just update the parameters using the user interface. They don't have to have any knowledge of how the simulation is built, or how to use Simulate. So before we get into Visual Logic, I'm just going to point out a couple of key features in terms of the interface. We have the command list, which is basically down the left-hand side of the screen, and that categorizes all of the different types of commands that we have within Visual Logic. There are literally thousands of different commands that we can use within Visual Logic to help us model our specific situations or record bespoke results. Obviously, I am just scratching the surface with Visual Logic in this little introduction, but we run training courses, for example, on Visual Logic. There's a whole bunch of different resources on our website on how to use Visual Logic, so you'll not get stuck. I'm also going to be working in the free edit mode, which basically means that I can type directly into the Visual Logic interface. If I didn't have the free edit mode selected, we would use the formula bar to kind of help us build up each individual command. But just in the interests of speed, I'm going to use the free edit mode. So, as I mentioned, we can really start creating some nice custom results using Visual Logic. What we're going to do is we're going to set up some Visual Logic which is going to look through all of the cars which have passed through that first section, and we're going to record if that individual car has met our service level. So this is a really useful type of result, and it's used a lot by our clients. So for example, working with our contact center clients, they obviously have very strict service levels. They need to monitor how many calls are meeting those service levels. Also with hospitals, if we wanted to look at how many patients were, or which types of patients were meeting the maximum wait time targets, we can use this type of result to help us calculate that. There was also a question last week about can we automatically import or export results with Excel. I think it's worthwhile answering that again, just to highlight how easy that is to do within our software. So I'm going to jump back into Simulate, and before we start writing any Visual Logic, I'm just going to click on the Visual Logic tab and show you a couple of different options that we have. We can set up Visual Logic to trigger at different times or at different points within the simulation. So for example, we can trigger some Visual Logic when the model gets reset. Or we might want to use the time check logic to record different results at specific times, maybe hourly, for example, within the simulation. We can also trigger Visual Logic on the objects themselves. So if I select an activity, click on Additional, and click on Events, you can see that we can record Visual Logic, let's say after the work item gets loaded into the activity or when it exits. Lots of different options. On the queues, we can record, or we can trigger Visual Logic whenever a work item enters a queue. We might want to do something there. Lots of different options. What we're going to do is we're going to wait until all of the results have been recorded on our spreadsheet, and then we're going to loop through that spreadsheet and record the individual, whether or not the individual car met the service level. So I want to do that when at the end of the run. So we've recorded all of our results in our spreadsheet, and then we're going to loop through it. We could obviously calculate this as the simulation was running, but by doing it this way, I can show you lots of different commands that we can use that are really useful within Visual Logic. So, as I mentioned, we have our search bar down the left-hand side and all of our different commands. If I hover over a particular command, we get a little description of what the command does and any parameters that we need to include. Parameter is just a piece of information, and if that particular command requires lots of pieces of information, we just separate each parameter with a comma. So what we want to do is basically loop through each row and see if a car has met the service level. We don't know how many rows we're going to have, so we want to use what's called a while loop. So as I start typing, you can see that Simulate tries to guess what I'm trying to say. The spreadsheet that we're looking at is our spreadsheet SS, and as I start typing again, because we've used our naming convention, Simulate guesses what we want, and it's going to be SS results. We're going to be looking at column 3, and we need some sort of counter for the row. So I'm just going to call this results row counter, something like that. Simulate doesn't know what results row counter is, so if I press my Control, Shift and Back key, I can highlight that word. When I do that, the Create button becomes active, and we can tell Simulate what this word is. I'm going to create it as a local data item, and it's going to be a number. I'm not going to go into global and local variables at the moment. There's plenty of information on our website around what those variables are. What we want to do is we want to keep running this while loop until we reach a certain condition. The condition that we want to stop running the while loop is when the cell is blank. So we want to keep going while our cell does not equal blank. When I do that, you can see that the line has turned blue, which means that Simulate understands what I'm trying to say on this line, and I can hit return. Previously, it was red, and I wouldn't actually be able to move off of that line. So as you can see here, I can't move away from that line because Simulate doesn't understand what I'm trying to do. So this is a really powerful piece of kit. It basically means it's impossible for us to spell anything wrong, which is a lot kinder to us than most other programming languages. So it's really easy to use in terms of a programming language. So what we're doing here is we're basically saying we're going to keep doing something. We don't know what that something is yet, but we're going to keep doing it with our while loop. And we're going to keep doing it until this spreadsheet reference is blank. Or to phrase it another way, we're going to keep doing doing whatever's within the while loop until we find a blank cell. We've got our little variable here called results row counter. We need to tell Simulate what value that starts at, because by default that value will be 0. And again, we can't look at row 0 of a spreadsheet because it doesn't exist. So before we get into the while loop, I'm just going to set my results row counter equal to 1. That means that we start looking at the first row. So if we look at this cell and it's not blank, then we're going to do whatever's within the while loop. And what we're going to do is we're going to look at column 3 and see if that's less than 300. So to do that, we use what's called an if statement, and we're going to say if that spreadsheet reference, column 3, and whichever results row counter value we're on, if that's less than 500, then we're going to do something. So at the moment, we've used 3 different commands. We've used our set command, which sets one thing equal to another. We've used our while command, which basically means that we'll keep doing something until a condition is met. And then we've used our if statement, which is basically us asking a question or checking a condition within Simulate. We're saying, is this less than 500? If it is, then we're going to go into the if statement and do something else. That something else is going to be to record the word yes. So if the car has passed through our first section in less than 500 minutes, we're just going to say yes, so that we can easily identify which cars have made it through within our service level. So I'm just going to set a spreadsheet reference, which is going to be SS results, column 4, because our first 3 columns are already taken up with our results, and our results row counter, whatever value that is, we are going to set that equal to yes. So when I add the final quotation mark, I need to use quotation marks because my result is going to be text. I can hit return, the line is blue. So we're almost there. We've almost built our first set of visual logic results. What we're doing here is we're setting the counter equal to 1 so that we start looking on the first row. We look at the first row and we say, is it blank? If it's not blank, then we go into the loop and then we say, is that spreadsheet reference less than 500? If it is, we're going to add the word yes into column 4. So we're almost there. We just need to move back out one step by using our Alt backspace, and then we want to add 1 to the results row counter. If we didn't, we would go through this little loop, we'd record the word yes, and then we'd do it again, and then we'd do it again, and we'd do it again, and we'd do it again, and we'd constantly be looking at the first row, and we're never going to exit from that loop, and our simulation is going to crash. So what we want to do is we want to add 1 to our results row after each iteration of the loop. So I'm just going to type in set results row counter equal to results row counter plus 1. So what we're saying here is whatever the value is at the moment, we're going to add 1 to it. So let's say results row counter was 3. We're going to add 1 to it, which is going to give us results row counter 4. We want to test and make sure that this is working. So to do that, I can add what's called a breakpoint into my code. A breakpoint is just a pause point, and I can set that up just using this little, or by clicking on any of these little circles. It'll turn red, and that tells me that there's a breakpoint. I can then close this down, and we can reset our simulation and run. The simulation will run, and we can click on OK. You can see that we get a little message pop up telling us that a breakpoint has been reached, and we can then enter into the code to start seeing what's going on. As I hover over results row counter, you can see hopefully in the lower left hand corner that we have a little description of the variable that we're looking at and also the value that's currently in that variable. So at the moment it's 0. If I press F8, that will move on the visual logic one line at a time. You can see that we've triggered that line of visual logic and where we were setting results row counter equal to 1. So as I hover over results row counter, you can see that its value is 1. Likewise, I can hover over SS results. I can see that I have a value of 70.64 and some change. Really useful thing within Visual Logic is if I click on a spreadsheet name and press Ctrl F9, that'll actually open up the spreadsheet for me so that I can see that I've got this 70.64 and some change. So that's the cell that I want to be looking at. If I press F8 again, we enter into the while loop because 70.64 is not a blank cell. We then say, is 70.64 less than 500? It is. So it's moved into the next line. So we're going to update column 4 with the word yes. Not sure if you saw that, but if I click on the spreadsheet name and press Ctrl F9, you can see that we've recorded the word yes within our row. So that looks like it's working. We then add one to the counter. So if I press F8, this time when I hover over our spreadsheet reference, you can see that it's 75.97, which if I open up my spreadsheet, I've got 75.97. So that looks like it's working. So I'm just going to remove my breakpoint and I'm going to click Run. All the visual logic gets triggered and I can click on my Data and Rules tab, click on my spreadsheets, click on SS Results, and you can see that I've recorded a yes for every single work item in every single individual work item which has made it through in under 500 minutes. You can see already that the first few work items make it through, but then we've only really got this one little lucky car here. The rest are all failing to make it through in under our service level. So this is a real key indication of a bottleneck for me. At the moment, our results look a little bit weird because we don't have anything input when our card doesn't make it through in the allotted time. So let's just add that into our Visual Logic. So I'm going to click on the Visual Logic tab and I'm going to click on Last Edited. That will open up the piece of Visual Logic that I was previously working on. And I just want to add a couple of lines of code in here. So I'm going to press Alt and backspace to move out of the if statement, and I'm going to type else. So what the else command does is it basically says if the if statement is not true, then we're going to do whatever's in the else statement. So if it's not less than 500, we're going to go into the else statement. If it's not less than 500, we're going to set SS results, column 4, and our results row counter. We're going to set that equal to no. And we can close that off with our quotation marks. The line turns blue. Let's close it. I'm not going to set up any breakpoints. I'm just going to trust my abilities. Click reset and run. This time when I view my, when I check my SS results sheet, you can see that we've got yeses recorded for those that met the service level and no recorded for those that didn't. So this is again a really powerful set of commands. Literally, you will probably not build a model that includes Visual Logic without using at least some or all of these commands. These are really useful for building up our bespoke results, helping us do really detailed analysis. So I totally appreciate that I've kind of thrown quite a lot of information up in the air for you, particularly if you've not seen a lot of programming before. But realistically, these are about as complicated as you need to get in terms of results or recording bespoke results like this. As I say, the session's being recorded, so if I've gone through this quite quickly, apologies, but you are able to view the video again when we send that out, and you can see again how I've gone through this. Once we've recorded our results, we can then export them if we want into Excel. Maybe we'll want to perform some detailed analysis or use some of Excel's charting abilities. What we can do is we can export that as and when required. The other piece that I was going to show you was related to the third webinar. We had a question asking if we could automatically trigger an Excel connection. The short answer to that is yes. I think it's definitely worthwhile talking people through that. There's a couple of different ways that we could do it. We can click on the Excel connection. Again, we saw how to do this in webinar 3. I'm not going to go into detail of how we actually created the Excel connection, but if I clicked on Properties, clicked on Advanced Settings, I could click on the Automatically Import Data Before Reset, and that would allow that to be executed anytime we press the reset button. What I'm going to do is do it in Visual Logic, just to give you guys another Visual Logic example. So I'm going to click on the Visual Logic tab, and I'm going to trigger this piece of Visual Logic anytime that the user clicks the reset button. I'm just going to hit return or enter so that I create that section of Visual Logic. I can type in my search bar here, Excel, because I know that my command is related to, I want to do something with Excel. As I scroll down this list here, you can see that I can import all Excel connections. If I double click on import all Excel connections, you can see that the line is blue. We don't have any parameters down here, so the line turns blue. Doesn't need any parameters, we're just importing all of them. If I've gone for a specific import Excel connection, you can see that I've got a parameter. That parameter is which Excel connection, or the name of the Excel connection. Easy as that. I can then just close down my Visual Logic section. I can press reset, and you can see that I get the little message popping up telling me that we are importing our Excel connection. Really powerful stuff, really easy to set up. As I mentioned, there's loads of support out there for Visual Logic. So we've gone through this quite quickly, but we've seen a lot. And once you get your head around those few commands, you can really do a whole host of different things within Visual Logic. So I'm going to kind of hand this over to you guys and see if there's any questions which you have or relating to Visual Logic or anything that you've seen today. Yeah, that's a really good question actually. So if we wanted to set up a user interface, let's just jump back into the software. If I wanted to set up a user interface, it's really easy to do. I just click on my insert button, or sorry, on my insert tab, and I want to click on this button option. First of all, I need to create my button, so I'm going to click on New. I can give that button a name. I'm just going to leave it as button 1. And then we can do a whole host of different things with this button. So we can open up a dialog, which is basically like a menu. We can open up an internal spreadsheet. We can execute Visual Logic. Whole host of different things depending on what the button does. So for example, we might have a run button, which executes a piece of visual logic which runs the simulation. What we're going to do is we're just going to open up an internal spreadsheet, because I've got most of that kind of already set up in the background through what we've been working on over the last few webinars. We're going to open up an internal spreadsheet, and it's going to be open up the SS timing spreadsheet. Doesn't really matter what the spreadsheet is at the moment, this is just for an example. We need to give that button an image. Let's click on the image. Hopefully I've got something usable on my desktop. I've got this simulate logo. Let's use that just for starters. I can select that and I can click on OK, and I can click on OK. I can then click on screen and that will add the button for me. I'm going to move this button. If I just grab, if I just grab the edge of the button, I can move it. It also counts as a click, obviously, so I'll just close that for just now and I'll show you how it works. So we probably wouldn't choose this as our final image, we'd make a bit of a better image than this. If I click on that Simulate Corporation, that will open up a spreadsheet and I can get my user to input any parameters which I'd set up. And I can click on OK. Just as a really quick kind of hint and tip for an easy way to put together buttons, I go into PowerPoint and insert shapes. There's a really nice little shape here that we can use for buttons, and I can type onto that. I can then save it as a bitmap and copy and paste that into my simulation. And that's a real quick way of building an image if you don't have time to kind of speak to a graphic designer or build your own image. Really nice, quick and easy way of doing that. But hopefully I've not revealed too many of our consultants' secrets. Yeah, that's another good question. So if I jump back into the software, what we want to do is, for example, let's record the contents of this queue every hour. I'm going to go through this quite quickly, just in the interests of time, but hopefully when you view this video back, you'll be able to see kind of how to do this. We want to record the contents of this queue every hour, so I'm going to set up a new spreadsheet to record that result in, and I'm just going to call it SSQ results. I'm going to click on let's clear it as well, just in case. Click on OK. I want to record this result every hour, so if I click on my visual logic, I'm going to do this using my time check visual logic. If I click on the lower portion of that button, you can see I can change the time check properties. So let's say we want to record it at the start of the simulation or at time 0, and then every hour thereafter. So that parameter looks okay. I can then just access the time check logic from this little button here. Click return. We need to record which row we are on currently, so I'm going to set up a counter for that. So I'm going to add 1 to whatever that counter is. So let's say we've got something called Q row counter, something like that. When I press Control Shift and back, the create button becomes available. I can create a global data item, which is a number. So Q row counter equal to Q row counter plus 1. So if it's 0, first time this time check executes, we'll add 1 to it and we'll be recording the results in row 1. What do we want to do? We want to look at the contents of the queue. So let's just close this, close this. The queue that we're looking at is queue for bodywork. So let's click on our visual logic, click on last edited. What we want to do is we want to set a spreadsheet which is our SSQ results. Column, it's just going to be column 1. Our row is going to be Q row counter, and we're going to set that equal to the name of the queue, which was Q for bodywork. And then if I want to access a specific part or a specific property of that object, so there's a whole bunch of different bits of information held within Q for bodywork. There's its name, there's its location, all that kind of thing. Part that we're interested in is its content. To access that, I press the dot or the full stop or the period, depending on where in the world we are. And we get a little list of all the different things that we can look at about that, that simulation object. Part that we're interested in is count contents. If I hit tab, the line turns blue, I can press return, and we can test and see if that works. I'm going to be confident in my visual logic abilities. That may well come back to haunt me, but let's reset our simulation. We execute our Excel connection and we run. I can now look at my SSQ results, and you can see the hourly contents of this queue as the simulation runs. And broadly speaking, every hour we are increasing, which again is a key indicator of a bottleneck. And we can start analysing this queue in a lot of detail using this type of result. So hopefully you can really see the power of visual logic, and you can see that it's not all that bad, especially in terms of programming languages. It does an awful lot to help you out. It's really useful. And as I say, there's an awful lot of support on the website as well. So we're kind of a little bit in danger of overrunning in terms of time, so I think that's probably all that we have time for at the moment. So I'll hand you back to my colleague.
Great, well thanks for that, Max. That was great. That is all the time that we have for now. However, we have had a lot of great questions come through, so if we didn't have time to answer yours, then we will be in touch soon. And if you have missed any of the previous webinars, you can catch up by clicking the link that'll be sent through the chat panel, and you will receive an email when today's webinar recording is available. So thanks again to everyone for attending this webinar series. We hope that you've learned just how easy it is to get up and running with Simulate. If you do have any questions about our different products and services, then please don't hesitate to get in touch with any of the team, and we'll be happy to help. So we'll see you all later, and have a great day.
Thank you. Bye.